Hi and welcome back. Another lovely question. How many terms of the arithmetic sequence 3, 11, 19 will add up to 1,580? Will add up to, adding up to simply means Sn, the sum of the actual series 3 plus 11 plus 19. They have already told us that it is arithmetic, so that means this is the correct formula to use. Please take note, you have an arithmetic and a geometric. So the sum for the geometric is quite different from the arithmetic. So let's try and solve for n here if Sn is equal to 1,580. So I will equate Sn to this, and then we're going to solve for n and see what comes out of this. So this is what I have. Obviously, I need to substitute the difference. My apologies there. And a, so let me just do my substitution. A is a 3, as you can see, and we do not know what n is. That is what we are solving for. And it is quite obvious that the difference here is 8. Take note, you don't say 3 minus 11, but you say 11 minus 3. Okay, now how do we solve this? It can be quite intimidating. What I strongly suggest is get rid of the fraction, because fractions are always a problem. So what I will do is I will multiply this side by 2 and also multiply the left-hand side by 2. So I prefer doing that because then I don't have to deal with fractions once I have done this. So when we multiply 1,580 by 2, I get here 3,160, and this 2 obviously takes care of that one there. 2 by 3 here is a 6, and then we can clean up a little bit here, so that gives me 8n minus 8, and obviously like terms, the 6 goes with the negative 8 there, and that gives you a negative 2. Keep the n outside for now, so you have 8n minus 2. And then obviously you want to bring that down. Then you multiply. This gives you 8n squared minus 2n. And this is obviously 3,160. What's going to happen now? Well, we got to form a quadratic equation. 8n squared minus 2n minus 3,160. I hope at this stage you know why I have a negative 3,160 on the right-hand side. Okay, seems like all these numbers, what am I talking about? Well, I'm talking about the coefficient of n squared here, the coefficient of n, and the constant term itself. All these seem to be divisible by 2. In other words, you can divide them by 2. So it makes life easy when we reduce our equation. So let's reduce this equation. If I divide by 2 there, I have 4n squared. And here I will have what? Just an n. And if I divide by 2 there, we obviously multiplied by 2 to get this 316. So this has to take us back to the initial value of 1,580. And I know you're going to be mad at me to say, why did you do this when we were going to go back to it? Remember, I'm helping you to cope, okay? So it really makes it easy when you eliminate the fractions. Otherwise, you could have left the fraction there, but I tell you, we get most of you there committing mistakes and forgetting stuff. All right, so what do you do now here? If your factorization is really good, go ahead and try that. But remember, the first equation we are given in our formula sheet is the quadratic formula. So it is still applicable here, even though we are solving for n and not solving for x. You can still use it. Why? Because the equation is quadratic. All right. So let us substitute. The coefficient of the middle term is a -1, so we're going to substitute. It is very important to show this substitution in your final exam. Don't just plug it in your calculator. I know you often do that. 4a is a 4, and we know c is a minus that thing. I don't have enough space, but yeah, I hope at this stage you do know what I am doing right now. So let's get the values. What are the solutions to this lovely equation here? I'm just going to use my calculator quickly as well. And I hope you also, gaining speed in the use of your calculator. You don't want to waste time pressing stuff there. And yeah, you end up not having enough time to attend to other problems. So we're expecting two values. The first one that I got is a nice natural number, the number 20. And the second one, guess what? I get a fraction or a negative 19.75. Now we are going to reject this. It is not applicable. Why? Because in number patterns, we expect n to be a natural number. What are natural numbers? Counting numbers, counting 1, 2, 3, etc. So we will reject this, not because it's a fraction, not because it's negative, simply because it is not natural. All right. Okay. I hope that is clear. You should be able, I like it when you try out things. So you should be able to do this problem here because it is the exact same thing. You're going to use the exact same approach that I used there. This one, it is also the same thing because what is happening here, they have given you Sn. Again, this here is Sn, and you just notice that this is actually arithmetic because there's a 9 there, there's a 9 there. Again, what is n in Sn? So it's a repetition, though it is asked slightly different. Okay. In the next video, I'm going to talk about sigma notation. Make sure you stay tuned.